Welcome to Relationships, a part one of a perspective on it's never ever really an accident. If we're going to develop relationship models and share them with each other, it's good if we have a common agreed upon method for developing them so that when one gets a relationship model from someone else, you sort of know what to expect in terms of the way that it's put together so that you don't have to figure out the conventions before you can begin to understand it. So the one that I have adopted was developed by the System Dynamics group at MIT many years ago for doing causal loop diagrams. And there's really only four kinds of things that one needs to think about when doing these diagrams, and that is we think about accumulations, which are often called stocks, which is a quantity of stuff which increases or decreases or stays the same over time, like principal in a savings account or water in a lake. Flows, which add or subtract from accumulations over time, like river flowing into or out of a lake, or interest added to a savings account. Variables, which are a constant or calculation used in defining flows and other variables, like interest rate for a savings account. And connections, which are links used to communicate information from one point to another, like the interest rate or principal influence, which influences interest. Now, we need a set of conventions to indicate how these things are used when we create diagrams. So the way that it falls out is the relationship between two entities can be adds to or in the same direction, meaning that the definition is overloaded because A and B can be different kinds of things. If A is the interest produced from a savings account, that adds to the principal in the savings account. So it's adds to. If you're talking about the interest that's used to create, or the interest rate used to create interest, it simply changes in the same direction. So if you increase the interest rate, the interest increases, and if you decrease the interest rate, the interest decreases. Whereas if you're talking about the relationship between the interest and the principal, if you increase the interest, the principal increases. If you decrease the interest, the principal still increases, just not so fast. So that you have to think about whether B is a variable or an accumulation or stock to understand which of these two terms to use. And this will become clearer when I do a more specific example. The alternative is that you can have a relationship where it subtracts from or in the opposite direction. So if we're talking about the relationship between a lake and a river flowing out of the lake, that river subtracts from the water in the lake, as opposed to something simply changing and having, if this gets smaller, this gets larger, and if this gets larger, this gets smaller, which means the change is in the opposite direction. If we look at the example comparing what happens with revenue and profit, if everything else stays the same and the company is currently making money, if revenue increases, then profit increases. If revenue decreases, then profit decreases. So the relationship is in the same direction. Profit doesn't accumulate, it's just a value. Additionally, considering expense, and ignoring this for a moment, you think about the way that the relationship between expense and profit develops. If expense increases, profit decreases, and if expense decreases, profit increases. So it's an opposite relationship. Whereas if you look at the relationship between profit and cash, so that for each month there is a profit, which if the company doesn't spend it, it adds to the cash on hand, so that the cash accumulates over time. So you look at this relationship in terms of profit adds to cash, as opposed to being in the same or opposite direction. So these are the two kinds of relationships that exist that will be used in all of the diagrams that I do. And I will be explicit in terms of whether the relationship is subtracts from or opposite, adds to, or same direction, because I'll define what the entity is that the relations are between. And it's probably a bit confusing at the moment, though as more examples develop, I'm sure that it will become absolutely crystal clear. It did for me after a while. So I did this in two parts because one part would make the video simply too long. So I'll see you shortly in part 2. Bye.